Let us talk about Introduction to Digital Signal Processing. I am Dr.Mrinal at Symbiosis Institute of Technology. We will be discussing today about Introduction to Digital Signal Processing. Very interesting topic. In this, we will talk about the introduction, basic elements of digital signal processing, advantages of digital over analog signal processing, then limitation of digital signal processing, applications, and a small mind map wherein I'll give certain small tips so that we all remember what has been taught in the entire session today. And we'll evaluate so that we know the outcome of the session and the references finally. Okay, so let us talk about digital signal processing. When we say introduction to digital signal processing, there are three key elements. Signal is at the heart of it, processing, and what are we doing? Signal processing. Which type of? Digital. Okay, so three keywords: digital, signal, processing. Now, when we say a signal, basically what is a signal and why are we so interested in this signal? Basically, signal consists of information, and we being an engineer, we are interested to extract this information from the signal, and that's the reason we are so much interested in signal. Now, let me give you a very good example. Suppose I'm teaching in the class. Okay, I'm teaching something on the board and I'm talking to all my students, and there's one student at the door who has come late. The student may ask, like, may I come in? And I'm explaining, and I do not want to halt and break my communication with all my students. So what I do is I just lift my right hand and I give him a signal that come in. Likewise, okay, so I just give the signal through my hand. So his brain, his eyes, the human body of the student basically captures, the eyes captures the picture that madam has waved off the hand, giving the signal, right? And the brain extracts the information from the signal. What is the information hidden in the signal? That you can come in, that I have given permission for the student to come inside, right? So this is what the human brain extracts the information and processes it, understands that information, and gives the signal to the human body, the hand, the legs, the entire body, so that the hands move, legs move, and the student comes inside, walks inside, and sit on the bench, right? So this is a very interesting example. So let me tell you, every signal consists of the information, and that's the reason we are interested to process this information, to extract the meaningful parameters from it. And why are we interested in digital signals? That is what we are going to talk about today, right? But before that, let us see what is signal and how is it classified. Signal basically, over here, we can say that it is a description of evaluation of a physical phenomenon. It could be anything, like suppose a weather forecast, in that the signal would be temperature, then sound analysis, it could be pressure generated because of the pressure, then if it's an image, say light intensity, say then gray level on the paper, likewise. So let me tell you, we can classify signal into two categories: analog signal and a digital signal. When we say analog signal, it is again classified into continuous time and discrete time signal, right? Now, analog signal means what? Basically here, it is like all real world signals are analog in nature, right? Take it a speech signal, image signal, a video signal, or any particular signal, right? It is all analog in nature. But when we deep dive into this analog signal, we understand that there are two types, like continuous time signal, which is like our sinusoidal signal, which is continuously varying with respect to time. That is, the amplitude is changing at every instance of time. And of course, here there are two variables like time as well as amplitude. Both are continuously varying. So I can give my students a keyword, CTCA. What is CT? Continuous in time, continuous in amplitude. So when we are talking about this all real world signals, It could be a speech signal. I'm talking to all of you. So I am generating, like my vocal tracts are moving in the air. There is a pressure created, a sound is generated. This is nothing but a continuous time signal, right? Now, if I want to convert a continuous time signal into a discrete time signal, I will use a process called as sampling, wherein I will not pass all the amplitudes, but what I will do is I will only consider certain samples of it. I'll come to that details in the next lecture. But now what I want my students to understand is continuous time signal can be converted to discrete time signal through the process called as sampling. Okay, now discrete time signal is available at discrete instances of time. So it is discrete in time and continuous in amplitude. So my dear students, here the keyword is DTCA. What is DT? Discrete in time and continuous in amplitude. Okay, so far so good. Let us move ahead. Now, digital signal. How to convert a discrete time signal to a digital signal? Because why are we interested in digital signal? Because our entire course, digital signal processing, we are working on digital signals, right? So now from the discrete time signal, we can convert it into a digital signal through the process called as quantization and encoding. And in the next lecture, we will talk in detail about what is quantization, how quantization can be done, encoding, and etc. But here what I want my students to understand is DT signal, that is discrete time signal, can be converted to digital signal through the process of quantization and encoding. Here, analog signal is very it is having so much complexities, like it is present continuously, whereas digital signals are very that way a particular processor can process it very effectively. Why? Because this is nothing but number. When we talk about image, it is in the form of matrix. When we talk about speech, it is in the form of array. That is, it is simple digital numbers, or a signal which is in the form of 1010 likewise. So the processing can be done very accurately, and there are so many advantages which we will be talking now. So here, digital signal processing, I am quite sure that you are very clear about this concept, right? Let us proceed further. Now, what are the basic elements of digital signal processing? The basic elements of digital signal processing. These are the elements which are shown in this block diagram. Now, our focus, our emphasis is on this digital signal processor, which is going to accept the signal in the digital format X of n, process it, perform the computations, and give an output Y of n. Right? Now, as I mentioned, all the real world signals are in analog nature, which is indicated as XA of t. How is this converted then? We are using A to D converter. That is nothing but analog to digital converter. That is, the signal which is in the form of X of t is converted in the form of X of n. Here the notations which we use is X of t is used to indicate an analog signal, and X of box bracket n is used to indicate a discrete time or a digital signal, right? Now, we require, as I said, XA of t is our input signal, which is a natural analog signal, and this signal is to be converted to the discrete time signal, digital signal. Here certain pre-processing is required and this ADC conversion. Similarly, as we perform this operations before processing, after processing we need to perform the reverse operation. Like if ADC is used at this particular point of time, we use DAC, that is digital to analog conversion. And here, as we have certain pre-processing, here we have post-processing. It's a reconstruction filter. It's a low-pass filter, wherein smoothing operation and all takes place. Okay. So here Y of n is the output which is obtained from digital signal processor, and digital to analog converter converts this Y of n to Y of t. Now our signal is in the analog format, but still here there are certain discontinuities present, certain smoothing is required, and certain reconstruction of the signal needs to be done. So we are using reconstruction filter. This is nothing but a low pass filter. Now we know what is a filter basically. Filter is a frequency selective device, And when I design a low pass filter, I will design to pass the low frequencies from 0 to a cutoff frequency. So all those frequencies, low frequencies will be passed, and the higher frequencies beyond the cutoff frequency will be attenuated or rejected, right? Then we get an output, which is an analog. So we started with an analog signal, and now we are getting back our analog signal YA of t. So far so good, right? So this is the block diagram for the digital signal processing. And in the next successive lecture, we will deep dive into each particular block. We will see how it works, and we will also look into the mathematical modeling of several concepts in digital signal processing. Let us talk about advantages and disadvantages. Now, there may be so many applications which may come to your mind which are digital as compared to analog, right? Now consider a clock, digital clock and an analog clock. Which is better? You will prefer a digital clock, right? A digital watch, because it is more giving you more accurate results, it is more flexible, then it's having ease of data storage, and because of that functionalities are increased. And the digital clock gives us operation also, which is very easy. Then multiplexing is there. You can use so many operation, like maybe you can also multiplex for calculating the footsteps, so that whenever you're walking, you will be able to find out how many steps you have to calculate. Whereas in analog, it is not possible, and there are so many other reasons. As I said, there are certain advantages, there are certain disadvantages also. So the system, because of digital signal processing, so many operations we are doing, the system complexity is high, it increases. And we know as system complexity is high, what happens is the hardware required is more, the circuitry is becoming complex, and because of that, power consumption also increases. And when power consumption increases, what happens is the battery life is also a question marks, but there is a lot of research which is going on, and it is moving ahead, right? So bandwidth restrictions are also another limitation, and power dissipation is another limitation, and we'll talk about it in the next successive lectures. Now think about an application, and you will find DSP applications in telecommunication, consumer electronics, instrumentation, image processing, medicine, and military applications, right? Now, let us sum up the entire thing what we have learned now into this mind map. This makes it very easy for all my students to remember what we have done in this entire session, entire small session. We talked about introduction to digital signal processing. In that, we focused on signal. Which type of signal? Digital signal. What are we doing on this digital signal? We are processing on this digital signal, right? Now, what are the basic elements of digital signal processing system that we have seen? That is the input, the pre-processing, the post-processing. Then there are several other things also which we are going to, we talked about, right? Then we also discussed about advantages of digital signal processing, that is DSP over ASP. We talked about application, we talked about limitations, we also talked about applications of it. So far, so good. By now, I am sure that you might have understood what is a digital signal processing course all about. This was just a small introduction to, and I'm sure that every lecture, every session, there would be some wonderful takeaway from it, certain tips and tricks for all my students to remember each and every concept very clearly, crystal clear way. Now, let us evaluate, let me know whether you understood whatever we have done. So digital signals and discrete time signal differ in. Now, what I request you all is you can comment. You can write the answers in the comment box. What is the difference between the digital signals and discrete time signals, right? So for another question, which I let me keep you all pondering on it, is what is the role of pre and post filters in DSP in the block diagram which we have seen. Bandwidth of DSP system is limited. Why is it so? Of course, I will give you all the answers also, but I'll give you a little time so that you can ponder on it, think on it, and you can text or comment your answers in the window below, comment section. You can text it. Okay, so DSP gives more accuracy than ASP because of why? That is what you are supposed to type below, right? Then list the applications of DSP in the field of medicine. And I give you certain links for additional videos so that you can study more and enter in the description window. These are the references. And thank you, students. That's all for today. And let us meet in the next lecture. We will start with some new interesting topics. Thank you so much.